Hey guys, let's look at a few more moderately difficult problems from percentage. The first one, the student scored marks in the ratio 1 is to 2 is to 3 is to 4 in 4 subjects. If the maximum marks in all subjects are equal and he scored 50% marks in all the subjects put together, in how many subjects did he score more than 50%? As you can see, there are 4 subjects. The scores are given as a ratio. That means the probable scores are 2x, 3x, 4x, where x is a multiple, which could be any number. Now, we don't know the maximum marks that is stated to be the same in all the 4 subjects. So you may choose a convenient number as the maximum marks. Let it be 100. Further, given that the student has an overall score of 50%, which means there are 4 subjects, so the total maximum marks will be 400, and the student has scored 50% of 400. That's the meaning of the question, which comes to 200. So we got the total marks of student as a 200 on the basis of the assumption of the maximum mark in each subject is 100. Now, total marks we can find out from the ratio in terms of x. This is the total marks, and that can be equated to 200, which I've got here. Now you can solve for x. See, this comes to 10x equal to 200, which implies x is equal to 20. Now, what are the different scores? See, it's x, 2x, 3x. So the scores are, that's 20, 40, 60, 80. So these are the different scores of the student in 4 different subjects. Of course, this is on the basis of the assumption that maximum marks in each paper is 100. So if the maximum marks is 100, this works out at 20%, this one 40%, and this is 60%, and this is 80%. And the question is about finding the number of subjects he had scored more than 50. Obviously, these are the 2 papers. He has scored more than 50%, and these are below 50%. So the final answer is 2 subjects. He has scored in 2 subjects more than 50%. Let's look at the second problem. If the speed of a vehicle is increased by 20% and the time for which it travels reduced to 66 and 2 by 3%, then find the change in the distance covered in percentage. Here we don't know the initial speed and time, and because of that we don't know the initial distance that it covered. So what do you do in such problems? Actually, this is a simple problem from time and distance. There also you see questions being framed in percentage terms. So percentage is so basic that you need to have a clear understanding because of percentage being used in various other contexts also. Okay, let's begin with, there's a simple formula in time and distance, which as you know is distance is equal to speed into time. Since you don't know the initial speeds, you may choose S as 1, T as 1, and accordingly D will be 1. If these two are chosen to be 1 and 1, it's okay. We can choose 1, we can choose 100. See, 100 I'm not using it because writing 100 here, there will be 4 zeros on the left side. You're wasting time on writing zeros too. As you know, time is time is a big constraint in all competitive exams. So write as least as possible and get to the answer, final answer as fast as possible. Whatever you write in the steps, they'll go in the dustbin. So final answer is what matters, unlike the system you had in colleges and university. Now what do? There are some changes made in the speed and time. Speed is increased by 20%, and 20% is nothing but, as you know, 1/5. That means 1 is getting increased by 1 by 5. So it will be this 1 plus 1 by 5. And what about the time? Time is getting reduced to 66 and 2 by 3%, and 66 and 2 by 3%. Write 100 here, simplify, you will see it reduced to 2/3. So 66 and 2 by 3% is nothing but 2 by 3. Now, this is just getting reduced to 2 by 3. Unlike here, we don't say this is getting reduced by 2 by 3. If it were reduced by 66 and 2 by 3%, I would have written 1 minus 2 by 3. As you have written here, 1 plus. I hope you can perceive the subtle difference between increased by something and reduced to something. This is actually 6 by 5. And the other one is 2 by 3. So what do you get on simplifying? This will be 4 by 5, which you can write again, converting into decimal, 0.8. So what do you see finally? With these changes made in speed and time, you got 4 by 5 as the new distance covered, which on conversion, you got 0.8. Initially, the distance covered was 1. Because of these changes, it has reduced. 0.8 is obviously less than 1. So it's been reduced to 0.8. And how much is the percentage change? The change is actually decrease. And the decrease is how much percentage? 1 to 0.8 means the decrease will be 20%. If you have any difficulty following any of the steps, like I wrote 20% here, these things are given in my previous videos on the basic concepts of percentage. And I would encourage you to go through those videos, whose links are given in the description below for your reference. Let me work out one more problem before concluding today's session. The question is, what if 70% of the students of a college are boys? The next year, the number of boys decreased by 10% and the total number of students increased by 13%. By what percent did the number of girls change? To begin with, we don't know the total number of students in the college, and the question is about finding a percentage value. So in such problems, as I have discussed before, whatever is not given, you will assume as a convenient number. This year, let 100 be the total number of students in the college, and 70% means 70 are boys. So obviously, number of girls will be 30. Now, what does the question say? This total number has gone up by 13%. That means this will become 130. 13% increase means it should become 130. Now, there are some changes in the number of boys. They say the number of boys decreased by 10%. What does that mean? 70 minus 7. 7 is 10%. And this works out to 63. This is boys. So obviously girls should be the remaining number. Totally 130. 63 boys. Obviously 50 will be the number of girls in the college. Now, what do they want us to find out? They are looking at the change in the number of girls. The girls' number, in fact, has gone up by 20. Initially, it was 30, and the next year it becomes 50. So there is an increase of 20. How do you convert that into percentage? The absolute increase you find as a percentage of the original number of girls. This gives you the percentage increase, which works out to 66 and 2 by 3%. So today we have discussed 3 problems from percentage, and the questions are relatively, moderately difficult. So if there is any step you are unable to follow, I recommend you do 2 things. 1, go through the previous videos of mine explaining the fundamental concepts of percentage. If you are still struggling with some of the steps I have gone through in the solution, you may raise them in the comment section as your clarification, and I'll address it there. Before concluding today's session, I would like to share a couple of points with you. There are 2 ways of tackling problems in a competitive exam. One is to learn the fundamentals and basic concepts clearly and then approach these problems. The other one is to Take a look at a few problems you've seen in some guides or coaching centers and try to replicate them. The success in the second approach is very limited because generally in tough competitive exams like bank, PO and CAT, problems are never going to be direct, rather they are a bit tricky. So to handle such problems, I would recommend you have a clear idea about the basics and the fundamentals. So I strongly recommend you go through the previous videos of mine explaining the basic concepts. See you guys in my next video where I'll help you with smart solution to some really tricky problems. Bye for now.